Today, we're going to solve three integrals. The first one is the integral of dx divided by a squared minus x squared underneath the square root sign. Whenever I see an integral that has a squared minus x squared minus a squared plus x squared, whether it's square root or not, I think make a trig substitution. Of course, if you have a nice simple integral like this with respect to x, it's a squared x minus x cubed over 3, be done with it and move on. But if it's a little bit more complicated than that, I would make a trig substitution. Now, when I look at a squared minus x squared, that's understood to be positive. The square root of this goes on one leg. The square root of that goes on another leg. I'll put it here. And the square root goes on the third leg. And we'll call that u. And to convince you it's right, when you square that side, you get a squared minus x squared, plus the other leg squared is x squared. This cancels out. You get x squared, which does equal the hypotenuse squared. That always works. Okay. So, we like a trig, so we want to solve for dx. I'd love to know what x equals. And I can see a fairly simple trig function like sine of u. It gives me x over a. X over a. The over a I'll put up there. This way, when I take the differential of the right side, I already have dx. The differential of the left side is a cosine u du. Okay, so I have dx in terms of u. There it is. Now I need to get this bottom. Well, once again, I notice with respect to u that that's the adjacent. I don't want to bring in x. I'll bring in a. Well, so that means we want the adjacent over the hypotenuse. That's the cosine. The cosine of u is the square root of a squared minus x squared over a. But I'll put the over a over there. So now I know how to write this in terms of u. That way. Ooh, I got it. I have everything I need. So it's the integral of dx. Well, this is how I write dx. A cosine u du. And in the bottom, I have this square root. A squared minus x squared. Oh, that's just a cosine u. And something nice happens. The a's cancel. The cosine u's cancel. You just left with du. And if I may, I will continue down here. So there's du. The integral of du is u. Now, we need to be able to express u back in terms of x's. Well, we come here. We know that a sine of u is x. That means that sine of u is x over a. Ah, I can interchange the x over the a with the u. So now I know how to write u in terms of x. I guess I should have said plus c there. So it equals to u, which is sine inverse of x over a plus c. Okay, I do not walk around remembering anymore that this integral is equal to the arc sine of x over a plus c. I do not walk around knowing that, but doesn't matter. I know how to prove it. Number 2, the integral of dx over x squared plus a squared. X squared plus a squared. That's one of the ones where I think to make a trig substitution. So what I do is I make a right triangle. Here's my angle U. Now since everything is being squared, the x is being squared and the a is being squared, then I just put everything under the hypotenuse. And the square root of this goes on one leg, and the square root of that goes on another leg. Okay? Now, once again, I need to find dx. So I try to find the simplest function that involves x. Well, x over a seems simpler than x over this. Once to take the differential of x over, that's where roots come. So I say that the tangent of u is opposite over the adjacent. The over the adjacent comes here. So taking differentials, a secant squared u du, that equals dx. Got it. Now, I need to get x squared plus a squared. Well, I kind of see it here. So I would love to divide that by just a. And that's not adjacent over the hypotenuse, not cosine, but it's the reciprocal of cosine, which is secant of u. And let's even square it. So it's the hypotenuse squared, which is that, divided by the adjacent square. Bring this up here. Okay, so now I have both pieces. There were only two pieces, and I have both of them. dx, right there. A secant squared u du. X squared plus a squared, the same thing. Actually, it isn't. It's a squared secant u. Okay? Secant squared u. So the secant squared u's cancel. 1a on the top for 1a on the bottom. So what we have is 1 over the a. Now, with the exception of that a, the only thing which I dealt with, the only thing that remains is du. So once again, I get 1 over a times u, or u over a, plus c. Well, what's u? Well, if you look here, which I'll bring down, you know that the tangent of u is x over a. You can swap those two. Not if there was an a in front. If you have tan of one thing equals another thing. You can swap those two things, provided you put an inverse there. Or if there already is an inverse there, get rid of it. Okay, so we have 1 over a times u. Tan inverse of x over a plus c. That's the second one. Let us prove the third integral. This time we have dx over x times the square root of x squared minus a squared. X squared minus a squared. Oh, x squared minus a squared. Maybe, maybe not. Maybe trig substitution. If I come here, I put u. When it comes to x squared minus a squared, excuse me, I didn't mean to put the square root. This is positive. The square root of this goes on the hypotenuse. One of the legs gets the square root of a squared, which is a, and the other one gets the whole square root stuff. One of the sides always gets that square root. Okay. Now, just to live up to what books tend to do, it doesn't matter, but how about we put the a down here? So now I want to solve for x. Why? Two reasons. I need to know how to write x in terms of u, and I want dx. So, from the last time, we learned that the secant of u is the hypotenuse over the adjacent. But I'll put the over adjacent there. That way, so now I know what x equals, which is good. And if I take the differential of both sides, a secant u tangent u du, why that's dx. Oh, so now I have dx. All I need is this. Well, how about I do opposite over adjacent? That's tangent. The tangent of u is the opposite over the adjacent, which is a, which I can put here. I have everything. I have all three pieces. Dx is written this way, and it's in the top, so maybe I should put it in the top. X is in the bottom. X is a secant u. Let me fix the top. I didn't put the angle u in. A secant u, and the square root stuff is a tangent u. Okay, a tangent u. Alright. Secant u cancels. Tangent u cancels. 1a for 1a cancels. And the a in the bottom I can factor out. So we get 1 over a du. Now what really surprises me is I don't remember, so integral of u, du is u. I don't remember these always working out to just computing the integral of du. Okay, so what's u? Well, you can come here and realize that secant of u is x over a, so u is equal to the secant inverse of x over a. So we have 1 over a secant inverse of x over a plus a constant. That finishes these three integrals. I hope you learned something from this. You don't have to remember. You can always come back and derive it. But if you're taking the class and you're doing, you should remember it because you're doing enough problems. I mean, man, it's painful to do this for 10 problems in a row. You just learn that this is the formula. Oh, Whatever a is, it's 1 over a secant inverse of x over a plus a constant. And if x is more complicated, then you do a u substitution and you get it in standard form, and then it works out smoothly. Watch and learn.